Hello and welcome to another episode of the Solana Development Course. Today we're gonna swap tokens with the token swap program. Now, the token swap program, I have not actually worked with this before, at least not as a dev. I might have used it when I was playing with AMMs long time ago, but I've never done this before, I guess. So should we just go ahead and jump right in? We're gonna see what we do today. By the end of this lesson, we will be able to create a token swap pool. Okay, so yes, we're talking about AMMs, automated market makers. I made a video about that long time ago. Check it out up there. There. Then we're gonna deposit liquidity. Well, that's like creating a token and then minting tokens. First you create a pool and then you put something in there, some liquidity, right? I mean, then we withdraw liquidity, this is the opposite of depositing, and then we're gonna swap some tokens actually using the liquidity pool. Amazing. TLDR, because that was already long enough. The token swap program is another SPL contract. Remember SPL, the Solana programming library? Token swap, here it is. A Uniswap-like exchange for the token program. So the token program, we are using SPL tokens here. Remember last time when we did this part, we created SPL tokens, and that's the cool thing of those tokens having one program. Then other programs can just use that SPL token program, and that way they support all of the tokens there are. Well, all of the SPL tokens, at least. And that's the cool thing about that architecture. You just use other programs and you don't need to build it yourself. That's what they are talking about when they say composability, which is using other programs. When I first learned about Solana, there was a lot of tweets about composability and how great that is. Now I'm starting to get what they mean with that, actually. That stuff, we can use other programs and we don't need to build them ourselves. And by using the token program, we support all of the tokens. And by using the wallet adapter, we support all of the wallets. Those kinds of ideas, right? Composability. And that token swap program is also deployed on DevNet. Fun fact, in case we haven't really talked about the three nets. So the main net, obviously that's the one where the value lives, the real one. It's still in beta, but we're still early. Then the dev net, that's for the devs to play around, where all the programs are deployed and you can deploy your own programs and test them there, where the sol is cheap, aka free. And then there's also testnet. And testnet is mainly used for testing Solana versions. So when the validators change to a different version, then they want to first test it on testnet. So testnet is more for validators, not for testing your programs. That might in the beginning be like, but I want to test my program. No, use DevNet. For production use cases, use your own deployment on a regular maintained by a reputable service. Apparently, Solana doesn't run one token swap program that they keep up to date, but apparently you can just take the source code that you find in here and deploy it yourself and then have your token swap program there, contrary to the token program where the token program is actually there and maintained. At least that's what James says. So since I have no idea about that, he is probably right. The program accepts 6 different instructions, all of which we will explore in this lesson. Amazing, we're gonna learn stuff. Then, developers are able to create and use liquidity pools to swap between SPL tokens that they wish. So SPL token to SPL token, that's what we're swapping here. Maybe I should have explained what swapping actually means, right? We have an SPL token and you want a different one, so you swap it and have the other one in the end. That's what you want to do. And for that to work, we need to have liquidity pools that hold both tokens, and you can give one in and get the fair amount of the other one out. But we will not get into the details of how AMM works. Watch the other video. Here we want to learn how to dev stuff. If other people tell us, hey, can you code me a liquidity pool program thingy? Then you can be like, yeah, I've done that before. The program uses a mathematical formula called curve. That's exactly what I don't want to get into, to calculate the price of all trades. Curves aim to mimic normal market dynamics. Mimic. Obviously, if you have your liquidity pool there, then people might try to arbitrage if there are other markets. We don't want to get into the economics of this stuff because we're not an economics channel, we're a development channel. So we get into the development of this stuff. Yes. Just as a disclaimer here, we don't do an economics class. And I don't want to discuss too much of like markets and tokens and token swapping, because if I do that, then people come here who are like, how can I make my token like Bitcoin? How can I set the price of my token? Where I'm like, piss off, this is not the channel for this. Overview! Let's talk about swap pools. Oh, damn it, we are getting into this. James, do you want to read that as a bedtime story for me? No, not even gonna let James read this. It's easy. I explained it in a different video that you can watch. Cool. Can we finally get to... Oh, there's a library. The SBL token swap library. Same as the SBL token library, we now have a token swap library, which lets us interact with that program. Who would have thought? Unlike the token program, there's no Solana maintained deployment of the token swap program. So if he says it so concretely, then it must be true. Rather, Solana provides source code for the token swap program as a reference implementation. So if you want to do that, you can deploy it yourself, or just create a market on Serum and integrate that into your front end. Throughout this lesson, we'll be using the deployment maintained by Serum. Oh, Serum has a deployment. See, they were smart enough to grind an address. And Solana maintains this JS library. Great! This library provides helper functions for interacting with token swap program. So helper functions like the create mint and create address that we had in the SBL token. Probably gonna find similar stuff here. Although I don't know because I never used it. Step 1, creating a swap pool. We showcase some conceptual things. That's much more what I want to learn about than AMMs and economics. This lesson will combine and build the top of all of what we have learned so far in this course. Oh, amazing. We need the knowledge that we gained before, so you can watch all of my previous videos. Oh, we create a swap pool for token A and token B. So creative. So creative. It's as simple as sending a transaction. Yeah, with the instruction create init swap instruction. However, there are a number of accounts that you need to create or derive beforehand. Namely, the token swap state account holds information about the swap pool. Okay, so each pool has an account that holds information. So far so good, I can follow. The swap pool authority. A PDA used to sign transactions on behalf of the swap program. So there's an authority that is owned by the program, and for it to be able to sign, it needs to be a PDA, such that it can sign. Then obviously we need the token accounts for token A and token B that will hold the tokens for the pool. So those, I'm assuming, will also be token accounts, so they're owned by the token program, the one we talked about last week, and the owner of those token accounts will be the swap pool authority, right? Because then the swap pool authority can sign that we can transfer tokens, because the token program requires a signature of the token owner, the transfer authority, which they still call owner. And so if we can provide the signature with the program for those token accounts, then we can transfer those tokens as the program. The pool token mint. So this is now a third SBL token that represents ownership of the stuff in the pool, right? Because in the pool, you basically need to have equivalent amounts, at least for those simple AMMs, of token A and token B. And you put them in there, and what you get back is this LP token. And then later, you can exchange that again for your token A and token B, possibly in different amounts. Hashtag impermanent loss. Hashtag do your own research. That's for the ones who provide the liquidity. The ones who want to swap, they just provide token A and then immediately get token B back. But therefore they pay a fee. Now I'm explaining what I skipped over here. Then the pool token account. So that is the corresponding token account for this mint. Yeah, so when we create the pool, we also create that LP token and put them in that token account. And then the pool token fee account. That's the account that gets paid the swap pool's trading fees. So the trading fees, possibly you can set that up. What you want them to be paid in, either token A, token B, both, or SOL would conceptually make sense for me, but we will see how it's actually done. Now, the token swap state account, to get more into detail of what this actually is. Before we can create a swap pool, you need to create a token swap state account. This account will be used to hold information about the swap pool itself. Okay, so it's literally we create an account such that the token swap program can use it, because this is just the instruction that uses it, compared to the token program. Compare last time, we also had to create an account before we could initialize the mint with the token program. So we had to create an account that the token program owns. Same thing here. We have to create another account that the token swap program owns. And the rent, we use again the token swap because that conveniently calculates the right size, because inside this library you will find the size of this, the layout. Let's get some coding done. Oh man, I need to install everything again. Let's make sure that we have all the relevant libraries installed. npm I and definitely Solana SPL token swap. What? Okay, maybe I just install this. Do you find this? Solana Web 3 is probably a dependency of it. Yeah, there we have it. Okay, cool. And in Solana, we already have Web 3. Yes, copying code. Then we're gonna, let's put that all in a function. Okay, moving on. So obviously we need a wallet. And last time we wrote such a nice function to load it. There we go. And then we need a new key pair. Bob. There we go. Bob, you, my friend, we're gonna set you as the default key pair with Solana config set key pair Bob. And then we might as well set the environment devnet. That's a quick way to write this under my head. Such then we can say Solana balance and see we don't have anything. But Solana airdrop us to Sol and boom, we have to Sol. So we have a Bob and Bob can now pay for a token pool. So my wallet will be loading Bob. And the Lamperts, we still don't know how many Lamperts we need. Oh, promise of number is not assignable to number because you need to obviously await this. James, did you ever like code the thing that you wrote there? I'm gonna make you a pull request for that as well, just to fix that. Just if people copy that, which most people don't, I do, then they can just use it right away, because people might not know what the hell is a promise. But then I would say, hey, cool, learn some JavaScript first. Although this is not a JavaScript class, but it's a Solana class. And here we should definitely await this before we can put it here. Okay, so we have the token swap account creation instruction, which is just the create account from the system program. And now we also want to add the actual create init swap instruction. Or what else do we do here? To get the actual implementation, where do you go? Well, obviously to the GitHub. But not to the program, but the JS side. And then the source. A layout index. Get min there. So we just get the minimum balance for rent exemption on the Solana connection with the token swap layout. And this thing, if we go up here, is exactly that. It's just a collection of fixed size things. So that has a fixed size, you know, that's what's stored inside of this token swap state account. We have some version if it's initialized, a bump seed, because remember when we talked about PDAs that I said storing the bump is useful. And then the pool token program, token A, token B, address of the token pool. That's the mint of token A, that's the mint of token B. So those are the token accounts, that's the mints. Then the fee account where the fee goes to probably. And then some uint variables like the fee numerator, denominator, that's all for the curve fee stuff, I think. Just some configuration. And then the curve type, because there seem to be different ones, and some parameters for that curve, how that should look, how quickly the price should change and whatnot. And that we need to store all in one account, and it has this size, you know, 1 byte, another byte, another byte, another 32 byte, another 32 byte, and so on and so on, and you can calculate that, and then you can get just a span of this, and that's essentially everything that this thing does. It hides getting the span and call the get minimum balance for rent exemption on the connection, but put that already all in there, such that you have a convenient function that you can just call and get the minimum rent for rent exception out there. Anyway, so should we... No, we don't want to execute that because we also want to add the other thing in their same transaction. So coming back here, what else? Program ID must be the token swap program ID. Obviously, because the token swap program needs to be the owner, because the token swap program needs to be able to change those values. And only the owner can change those values. Owner now being in the sense of a account has an owner, which is the program, which is different to the holder or the authority or whatever you call it. We need to write data to that new account, so it must be set as the owner. What I said. So I want to get this to work. So I want to call this token swap create init swap instruction, which is going to do this. So we have the token swap state account creation instruction, because here we just create your account. And then we're going to do this token swap state. My naming is not particularly on point, but it doesn't matter. It's just so. What do we need here? We need the token swap account. We just generate a key pair. We don't provide the specific key pair for that, but we just use this one. That's fine. Then we just also use this one here, the pub key of that. Then the authority. Let's say we are the authority, because the authority is the PDA used to sign transactions on behalf of the swap program. Okay, so we're definitely not the authority. So we need to first create the swap pool authority. We do need to do this first. Cool. So this account is a PDA derived from the token swap program and the token swap state account. The state account and the token swap program ID. The program itself is not part of the seeds as it is with Metaplex. So it's this token swap state account that we just created. Yeah, okay, so let's do that first then. We create our swap authority by using find program address. And those are my seeds. It's just that one address. And then we can provide the swap authority here. The next thing we need is the token account A. Okay, and then conveniently James is talking about that right here. I mean, how convenient. Thank you, James. This would be the authority for many of the accounts, pretty much all of them that are not directly owned by the swap program, like all the token accounts. We totally know what we're doing. I'm gonna copy some code here without actually reading it. Token A, account address. We need to import SPL token. NPMI. And once we've installed that, is that how he wants it, as token? And then he says token dot. Well, we can do that. Okay, cool. So the mint, again, now we need token A and token B. Wait, do I have SPL token here? Yes, that comes with the Solana CLI probably. So let's just create two tokens real quick. And of course, we're going to grind them. We're going to say B token. I want an A token. A tot and B tos. SPL token create token and provide those things. B token. Default decimals are 9. I'm fine with that. Cool. Now we have those two as tokens. So we're gonna const them in here. Token A mint is what he called it. Is a new public key of this thing. And then the same thing for token B. Oh yes. Here we go. Cool. We have that. So mint owner needs to be the swap authority. So that's my PDA from above. Important, very important. That's the PDA. And also we need to say allow off curve. The default is false. So we need to explicitly say here we want to allow this ATA to be off the curve. Why off the curve? The owner can be off the curve. That's just a security check where it checks, is that actually on the curve? Just to make sure that it's an actual user wallet. But in this case, we know it's not a user wallet, it's a program's wallet. It's a PDA. So we must say, hey, allow that. Please let that PDA be the owner of this token account. And then we create an associated token account instruction. So here we just get the address, and then here we actually create it. We don't put it on chain yet, but we get the instruction. Token A account instruction. And then we do the exact same thing. And if you do two things at the same time, you should make it a function. Function here for you that does all of that stuff that we just talked about, just not for token A, but for a general token. And we put just the mint here. Oh, we need to make it async because it has to await. So gotta make this a promise. Return this. We also need to pass in the swap authority and the payer. Cool. And then we call that twice. Waiting this for token mint A, swap authority and wallet pub key, and both of them are then token A instruction and then token B instruction, or token A create instruction. Tessie and Tpsi using speaking variable names. That's how I teach it. at university. Not here. Here I use Tessie, but I explained what I mean, so that's enough for my taste. Okay, so we have those. Now we have the token accounts. We could already make progress here. I'm not remembering the account. Can I also just get a pub key here and then return this here? Left side of comma operator is unused and has no side effect. Can I tuple them? Not really. That's probably a function what I do here. Let's just try stuff. Python programmer tries to JavaScript. That seems to compile. Maybe that works. Because I want something like this. These, there, square brackets. So, square brackets, we get a token account, but that's an associated token account. No, let's call it token account. Token A, token account. And then this I leave like that. And then token B, token account. Yeah, does that work? And then here I will have the token A token account followed by the token B token account. Yeah, if we need a refresher on that stuff, watch the previous video. Pull token mint is the next thing we need. Again, we need another token, which is the LP token. But here the mint authority must be the swap authority account. Okay, so that's because the program needs to be able to mint. Makes sense. So let's do that. Like before, create another token, and I want a specific address. So I'm gonna grind again. This is the LP token. Okay, what do we do with this LP? Well, of course, we SBL token create. Do we need any specific requirements for that? 9 decimals should be fine. I don't need the freeze authority, but I can already provide the mint authority by saying mint authority, and then providing this address, which obviously is gonna be different if I use a new key pair every time. So we're gonna use a fixed key pair here. And how do we get a fixed key pair? Well, obviously by Solana keychain grind. So this is the token swap state, just TS. Swapski. Haha, couldn't have come up with a better name. Swapski. There you go. And then we have this authority fixed. So let me just print this. Swap. Comment that out. And TS node. The swap authority will be U by K9. So this we can now use as our mint authority when we say SBL token create token. And then we said the TS should be our created token. The T-sky, did we want that to be the... No! I made a mistake! I lost my arms for it. I put the wrong thing here. We wanted the LP to be the token and not this thing. And now this thing is the token and you can't delete tokens. Token means. Let's do this whole thing again. And grind ourselves another TS. Gotta replace that real quick and then run the previous thing again, because now obviously also the swap authority changed if I change that key pair. But my swap authority looks funnier now. And with that, it's gonna be my mint authority. And the LP is the thing that we wanted to have as a token. So we create from the LP. So we have that as the token and that as the authority. Let's check that on Explorer just to make sure. There you go. Unknown token and the eager TB is the mint authority. That's important. Cool. Which means we can move on here with that thing and provide the next thing, which is the token pool mint. So for now we have just this. Token pool mint is, we don't need the key pair, we don't need to create it. Okay, so that's the LB token mint. And then with, yeah, it would have also made sense to do that in the code. I'm just so used to doing all the token stuff with CLI. That's why I did it with CLI now. But yeah, it would have totally made sense to just do that as well as an instruction. I mean, we did it like this now, so that's okay. The pool token account is the account that the initial liquidity tokens get minted to. This pool token account from the pool, he creates just a new key pair for that. Okay, can do that because it doesn't need to be the associated token account. But actually, why not use the associated token account of, I don't know, the swap authority or some shit, I don't know. Anyway, new keeper will just be fine because it is then anyway stored in here. Whatever that address is will be used. Okay, let's do it like that. Here you await, that's good. Pool account rent. To get the right rent here. And then we have a create token account pool instruction. So that's again a create account and an initialize account. See last lesson. And then we can use the token account pool for in here and just a pub key of that. Cool. Next thing is the token pool fee account. The token pool fee account is the token account that the fees of the token swaps are paid to. Yes, we're using the one from Serum, so that must be the owner. Here I would really like to know why it's that, or where that is derived from, because I would like to derive that from, say, the program account with some, I don't know what, seeds. Then it would make sense to me, but just giving it to me as a magic number or a magic public key, magic account, it's like, okay, I mean, I take it. Let's just take it. Is that the exact same thing? Create associated token address, create associated token account instruction that we put in our nice little function above? Yes, it is. Just that the owner is now different. So maybe let's also call this owner. Then it's so generic that I can use my function again. This was a pool token account and pool token account create instruction to be consistent in my naming strategy. And then we await our nice function with a pool token mint with the fee owner and with we are. So then I get token fee account address. My bad, that's what it's supposed to be called. And then I said token fee account creation instruction. We can provide the fee account. So that's again a token account. Next thing we need is the token account pool. I would say we already have that. And then the pool token program ID. Now we're ready to actually create the swap pool, right? So with the create init swap instruction that I'm trying to build the entire time. After that comes the constant representing the token program ID used for this pool, right? So which token standard we use. We want the one from SPL, that classic token. So we just say from SPL token program ID. And then from the token swap program, the program ID. And then come some configurations that he discusses in detail here. Next, 4 pairs of number arguments representing numerators and denominators of trade fees. Okay, let's try to at least understand this a little bit so that we know what we do. Let's explain each of the fees. Trade fee. So this is what the LP providers get whenever somebody does a trade, so a swap, then a percentage goes to them or something like that. Owner trade fee. So that is what the program itself makes. The owner withdrawal fee. So again, that's how the program also makes money off the LP providers. We don't only want to get fees from the swappers, also from the LP provider. And then the host fee. Oh, that's for the front-end hosting. This fee incentivizes external parties to provide front ends for the swap pool. Yes. So if you host your own front end, you can put your address here for the host fee and get a little bit of that. Trades that occur through your front end. When using a swap program, let's not have a trade fee. Can I have also like 0 here because I don't want a trade fee? Whatever, I put 100. The owner trade fee, so that's what we get as the program. So James says 5 over 10K. Why not? And then the owner withdrawal fee. So if you get the liquidity things out, again, we don't want any. Oh, I'm starting to understand this, I think. Since we store those things as integers, it's much better to provide a fraction than it is to provide an actual decimal value, because decimal values, floats, is not what you want to store. You want to store integers because they are concrete and exact. And to get an integer with, 0 points, you need to provide a fraction. That's why we provide in the numerator and denominator. That makes sense. Ha ha ha. Learn something. Thank you. Who explained you that? My brain did. The host shall get 100%. No, that's stupid. 5%. That's also a lot. Maybe let's say 1%. And the curve type we said is this curve type constant product. And curve type is hopefully in the SPL token swap. Yes. Cool. Now we almost have everything that we need here. Anything else we need? We can have curve parameters, but this one probably doesn't need them or has default stuff. And with that, that's it. That doesn't even complain anymore. Great. Now the question is, does this actually work? We will see. So we created a lot of instructions here. We need to put them all into one transaction and then send it. We already started with a transaction here. Should we just put it all into one transaction? Yes. Probably that transaction will be too big if I add them all into one transaction. But hey, we can try. Oh, you don't want the pub key? Okay. The account token swap account. Where did I get that from? Worst thing that can happen is that it doesn't work. Should we do it in 2 steps? 1 step. And this transaction will definitely be too big. This is probably deprecated. We should use a version transaction. I've talked about version transactions in a different video, which should be out by now, so go check that out. But I'm lazy, I'm gonna use the deprecated version. And then that should be fine. Except the transaction will definitely be too big, but let's try. Let's see what happens. The error is that it doesn't like key pair because it's not of type account. What is account then? Since please use key pair instead. So the implementation of this library is also not up to date anymore. Or maybe I just don't have the newest version of this. Maybe SBL token library does, which is defined in token state account. That's a token account? No, I think GitHub is just messing with me now. Import account from Solana Web 3. So it's in Solana Web 3, not in token account. You're just messing with me. Man, I don't want to work with deprecated stuff. Gotta get deprecated stuff to work. Account. So that's the token swap state account as an account. There you go. So can we now, in this goddamn deprecated way, send this transaction? Signature verification failed. No. Okay, well, first of all, we do something like that. But then also, so we just create this thing, then we create those things. Up until this point, everything should be the same. So let's just do this once and for all. Boom. No, we already have here the signature verification fail. What do? I create an account and yeah, that account then also needs to sign, of course. Fine, there we go. Let it sign. Works for me. Does it work now? Yes. The first one. So that's classic debugging. If all of it doesn't work, let's do the parts. So here our Bob creates 2 token accounts and this TS, which we said was for the token swap state. So that's working. And since I always use the same tokens and the same swap state account, we can say this is done, because if we do it again, then it will fail because you can't create the same account again. Yeah. 0x0. So we don't do that again. We make a new transaction. Into this new transaction, we now add the remaining things. So here we again create an account, and the new account pub key is this token account pool, which again, then if we provide it like this, we need to provide as a signer, obviously. Down here, when I send it, I need to provide this as a signer and see if that works. Custom program error. So this is now already where we can send that transaction, but the program itself, so probably the swap program, but then the swaps, it doesn't like something. 0x4. Now, since that's from a custom program, gotta look up what that means. Token swap program should have in the source code some errors. Here we have 0.4. So the error is, if I counted correctly, deserialized account is not an SPL token mint. We have token swap account, which is an account. That's good. The authority should be good. The token account A, token account B, and then the token pool. What do you expect here to be a mint? Mint A and mint B. That's what you store. But did I give it to you? So this just takes token account A, token account B. Oh, maybe the token pool is the mint. Token A, token account, token B, token account, swap pool token mint. Okay, so we need the pool token mint, not the account. So we need also the pool token mint. Well, at least the debugging works. Just need to know how to read error messages. See, that's the advantage. If I make mistakes, then at least you know how to debug this in different error. The swaps now tells us 0x6. And 0x6, since we already conveniently opened that here, 5, 6 is empty supply. Input token account empty. You need to have tokens in the account. Well, I didn't know that. I didn't read the upper part. So for that, we should now understand what those pools actually need. Wait, did he say something about the initial pool tokens? So should I give you some initial pool tokens in your token count pool public key? But we don't have the mint authority for that. We set the mint authority to that program, or to the authority that the program owns. So we can't mint them anymore. But maybe you're also talking about the pools A and B. Maybe they can't be empty in the beginning. I mean, I could read source code and see where that thing is if I were to really want to fix this processor. Yes. So this is thrown if token A account. Why is he trying to mint token here? But anyway, we get this empty supply when it checks for empty token A and empty token B. So maybe we just need some tokens in there. So let's just do it. And why not do it with CLI? Because that's quicker. We had the token accounts, where we create them. Let's also lock that just to get those. There you go. I don't need more. Just need to see those accounts. Perfect. Then I just say SBL token, because for those I still have the mint authority. Mint, what was there? The A token. We mint 1,000 tokens. Who cares? Then we provide recipient token account address. I can just put it as the third argument. And I'm gonna put this thing I minted into this account, and then we do the same for B. So SBL token mint the B token. 1,000 into this B account. Now they hold tokens. If I run this thing again, damn it, the input token account is empty. Oh, that's a test. That's why we mint. Oh, that makes sense. This test tells us that initialize swap should result in an empty supply if the mint is 0. Maybe we should just do the demo, but I kind of want to get this to work. I kind of want to find out what my error is here. What is the input token? But they are not empty. There's definitely 1,000 tokens there now. Oh, maybe I executed it too quickly. Let's try it one more time. Yeah, that was it! That was it! I just executed too quickly! It's so good, obvious that even my green screen is celebrating with me. I didn't wait for the confirmation and for it to finalize. I just minted the tokens and then I immediately did the execution again. Those two still hold 1,000 tokens. This one was another one that was newly created with the same LP. So that those two were created. Those are associated token accounts. The one we created with our create account and then initialize account, and the other one was created here inside this with create account and initialize account inside the associated token program. And then as the fourth instruction, there we used the actual swaps program, which did a mint. It minted 1 token. So actually it minted 1 billion of whatever. Yeah, what does it say? Init mint 2, that's it. We've initialized the thing. Now, great Andy, we've initialized the thing. Amazing, cool, Now, we need to actually interact with this pool. Because so far we created one, okay, fine. But then, how do we actually swappity swap? I think I'm gonna skip those. But I definitely do wanna execute a swap. We swap tokens using the swap instruction. A token swap. That's the state account. We have that. The pool authority, we have that. The delegate over the user token account. So the user itself is a token account and they need to set the delegate such that the program can then get out tokens of their token account without the user signing. The user still signs. So it's within the swap program, they do a CPI on the token program and they can then only sign for themselves, meaning we have to have a delegate. User token account to transfer tokens into the swap pool source. The user sends them there to this swap pool token account. User destination. So that's the opposite of that. The pool mint, we have that. That's again the LP token mint address. The fee account, we have that. That's the random magic number public key thingy. Then the host fee account, that's the address which receives the host fees, which is an optional parameter, because the host, the front end, is the one building the transaction. And if the host, the front end, decides to put null there and, say, I don't take any fees, then that's fine as well, right? And if you compile your own front end, you can put that there. Or if you make a manual transaction, then you can also say, oh, I am the host for this manual transaction now, right? The swap program ID, again, we need to know which program we're interacting with and which one the token program is, and the amount in. Obviously, we need to say how many of the tokens we want to transfer to the pool. Maybe we should look into withdrawal and thing as well, but for now, stay here. And then the minimum amount out is for slippage. And if you don't know what that means, basically, since when you perform a swap, that changes the price. So the combination of those two, right, with the curve that it can happen that you want to swap for a certain amount, and then somebody else was quicker and had their transaction before you, and that changed the price so much that now you would get out a lot less. That's why you can define that minimum amount that you want to have, and otherwise the transaction will fail and say, oops, can't provide that much anymore. The price has changed too much. So slippage got too big, and so the transaction fails. So if we provide the minimum of 0, then we say, whatever happens, happens. We don't care about slippage, even if it's like 100%. The instruction for swapping token A for token B will look like this. Don't need that stuff anymore. The swap instruction. Let's do this. Well, that was the swap authority, right? The user transfer authority. The delegate is the person who can sign for transferring tokens out. And if it's myself, then I don't even need to set up an actual delegate, like in the token delegation sense. But if I can sign myself, then I can transfer myself. And since I signed for that transaction, maybe it works that since I just signed for that transaction, the program can then transfer tokens out. I mean, that kind of makes sense. Bob is the delegate. SBL token accounts. Hold on, but then maybe I do want to create another guy. Otherwise it gets confusing. So let's create ourselves a Alice. Ellie. No capital I and no lowercase L. That's how we do it. Yeah, that's how we spell Alice. That's too much, so just Alec. Alec! Maybe that's also even too much already. There. Then we say Alice. And now let's work as Alice, get ourselves some sol real quick. And then, since I don't want to do it all in the program, SBL token create account for token A. Let's see if it does it for us. Probably it should do it for us. So then we just mint. No shit, we can't mint. Only Bob can mint. Okay, but anyway, here we have the token account. So that's const Alice token A. ATA, the new public key of this. It's so annoying that the SBL token CLI doesn't let me provide a key pair. At least you can have 100 into your token account. Then we just provide as the user source the token ATA, but then also now we're not working with Bob anymore, we're working with Alice. So I put Alice's public key here. Next up, in this wonderful list of stuff that we need to provide, the pool source. From Alice, we send token A into the pool destination. Pool destination must be token A as well. Pool source will be token B, because what we get back is token B. I'm starting to understand this. You just need to work with it. Pool source and user destination will then be the token B things. What is the token B token account of the pool? Is the pool source, and the pool destination is now the token A token account, and the user destination, that must now be, you know what, I do create it for you, Alice. SBL token create account from the token B, which is this, with owner create an account from the B token and set the owner to Alice, since I'm doing this as Bob, and then Alice has this token account, so const Alice token B ATA is this thing. And then we provide the Alice token B token account as the user destination, because we want token Bs and we send token As. Pool token mint. Fee account, we have that, and we don't want a host fee. And the swap program is the token swap program. And the source token program is the token program. funny. I can swap a token with one token program to a token from a different token program. So I could swap a token 2022 with a legacy token. That's funny. But in any case, also the destination for us will be the token program. Just the regular token program. Good. The amount in. So this is how many tokens Alice wants to swap. And I just created not even 1,000, but like with 9 decimals. And we have 100. So maybe we just swap 10, you know, this little. The pool token also can have a different, of course it can. Everybody can have their own token program. But now I provided it often enough. And I can say 10. I want to swap 10 tokens, please. And since in the pool there's 1,000 and 1,000, I would expect if I put 10 in that I get 10 out, or at least approximately, probably 9. Those numbers are really small because I ignored the decimals. I forgot to multiply with a billion. Anyway, it's fine. And the minimum amount out is 0 because even if we don't get anything, we still accept it. Even if we lose our 10 billionth of token A, then that's fine as well. Good. Close that bracket for the 3rd time. And then we have our instruction. So that's our swap instruction. And I think that's pretty much all we need. And then we just send it and provide the signer. And the signer needs to be Alice. Alice needs to sign this and we should be able to perform a swap. No, Alice cannot swap. Error 0x13 is not actually the 13th error because obviously this is hex. And I've made this mistake many times, counting to 13 and being like, well, that does make sense. So you could be stupid and count to 10, 11, 12, 13. General calculation failure due to overflow or underflow and be like super confused why that is the case. But no, this is of course 1, 3, which is 16 plus 3 because we're hex. Pool fee token account incorrect. What is our pool fee? That was probably that one, right? Wow, amazing. Well, or error naming. But with that, save and try again. Pending. Yes. Woo! I celebrated too quickly. First of all, I forgot to await. But secondly, it doesn't work anyway. Because this time we have 0x3. Output pool account owner cannot be the program address. That's also very specific. This thing cannot be the program address. The owner cannot be the program address. It is not the program address, it is something derived. Okay, I'm gonna again cheat a little bit and check how James did it. Token swap state account, swap authority, and then the next thing is the user public. It kind of makes more sense to have A, B. That's why the order is like that. I kind of effed this up. So if I, as Alice, want to send token A, does source just stand for the type of token? So there's the source token and the destination token? Is that how you make that naming? So it's user token A and pool token A, and pool token B and user token B. And we send from here to here and from here to here. If that is the case, then again, my earlier explanation has been wrong. Well, not wrong, but with the association to those was wrong, which could be. So let's just do this and swap those around because we are swapping stuff here. Well, this is the whole topic of this. I mean, does that now change anything if I just execute that again before we analyze any further? Yes, it does. And it just goes through. That error message was a bit confusing again. Sorry, I must admit, but works for me. We swapped. Let's look at it. We, as Alice, provided a shit ton of accounts. And then, here happens the swapping, received 8 tokens. So 10 we sent, and the pool received 10, and the pool sent 10. So sadly, we don't have the owners of each of those listed here. That would make it nicer to watch, but that's pretty much what happens. There was no fee deducted. I did mint 1,000 tokens. Hold on, but then I can do this with 10. Hold on. We can do this with 10 to the power of decimals. So this is now 10 actual tokens. Let's do that again and see if that changes anything. And see if we can if we can do a second swap. Which, goddammit, we can't. 0x18. Incorrect token program ID. What? Does not match the token program expected by the swap. Are you effing crazy? If I remove that again, does it work again, or is that then the same error? Ah, here it works. 1, 2, 3, 4, 5, 6, 7, 8, 9. Suddenly it doesn't work anymore. It's even written here. I don't even need to look it up. I'm just blind. The provided token program does not match the token program expected by the swap. We're not going to get into detail why we get this error, because this just does not make any sense to me whatsoever. So we can provide a number or a number 64. Okay, to learn something, I do want to learn how to use this number U64, which is their own big number thingy. And how do we create one? From buffer, and the buffer we just provide 2 bytes. Let's try that. So we want 64 bits. So we want 8 bytes. And then we amount buffer write a big integer in little endian. Oh, this is amazing. And there we just write 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm getting sidetracked and just... But as long as we're learning something, I'm happy to go into rabbit holes like this. So we now have the amount buffer, and then we just, with this buffer, create our number U64 thingy. And then with that, still, god damn it. My assumption that was the error is apparently wrong. If I were to do it with 10 now... Oh no, that works again. So it's a BS in the implementation. But hey, at least we learned something around the buffer. I think I want to end it here. That's how you call it. You can deposit liquidity to get LP tokens back from your LP tokens. You can withdraw the liquidity. And it's again just providing a lot of, accounts that you need for that, and then it's being done for you. So it's not particularly interesting. Deposit all token types instruction. So this is a symmetric deposit for A and B. There's also deposit single token. So it's a bit more complicated than a Uniswap, which always has a pair where you need to provide both equally. Maybe let's quickly do the withdrawal liquidity, because it's literally just providing a few more things. Let's try if Bob can get out his liquidity that he put in there when we created this pool, and after that we call it a day. So both of them out. Not gonna do that, but we're gonna get a withdraw instruction with the following parameters. The token swap again being the token swap state account, then the swap authority, user transfer authority, the pool mint is the pool token mint, the fee account is the token fee account address. Yes, this one. Then the source pool account. So that's the liquidity pool. So that's the LP token address. From this LP token, we have the create token account. So once for ourselves, where we got this one, that was the one where we generated a new key pair. That was Bob's. To make it nicer, I should have used the ATA. Give me the address as well. The C9. That's where my LP tokens are. So let's just call it that. Bob's LP token account. Just gonna use that. Stupid. Should have used the associated token account. Just saying. So from A, from B, user account A, user account B. So that's the A and B like we had it up here. Token A, token B first. And then the Bob's token A and token B. And since we didn't create them yet, let's SBL, because we directly minted into the account for the pool. Token A, Bob's token A. And then for B, that's this one. Just using the ATAs. Again, could do it programmatically, but can't be bothered. And could copy this, but also can't be bothered. Make my hands write more. That's A, that's B. And then user A is Bob's token A. And then user B is Bob's token B. And then the swap program ID is again the token swap program. And then, so we have token program ID 3 times as above. And then we need the pool token amount. So this is how many of our LP tokens we want to put back there. And that I think is 1, like it's that amount. It's 1. But since we are dealing with 9 decimals, I created it this way. It's 1, 2, 3, 1, 2, 3, 1, 2, 3. Minimum token A, don't care. There will not be slippage. I don't care about it. And we get a transaction. instruction back. And this transaction instruction, we can then send again. Send it. So this, celebrate if it actually works. Doesn't even. Oh, because I'm signing with Alice. Well, obviously. Okay, that makes sense. Good catch. I'm signing with my wallet because that's Bob. Okay. Yeah! We did something! What happened here? We, Bob, paid for this transaction. And we, Bob, paid our 1 LP token back. Yeah, that was the 1 billion that we wrote in there. And therefore we got all of the remaining stuff out from the pool. Like all of the token A's and all of the token B's we got into our token accounts. There's no more liquidity now. We could then go ahead and deposit again. So that's the opposite of withdrawal. But again, you just provide these things. I'm not going to go through that now. You can do that as an exercise. Same with the curves, some theory on curves and how you would change that. Again, I don't judge this topic to be so important that we need to go over this now. I'd rather have you understand the token program really well than understand the token swap program, because how often do you need the token swap program, right? And the token program you need all the time. So I leave the demo up to you as a homework or as an exercise or as whatever you want it to be, as a nice evening literature or whatever. You can do that, where James probably goes over the exact things we were just implementing here in this example, just that he also has a front-end application. And then there's also another challenge if you want to do it with your own tokens, like we did. We created our own tokens and did it with that. It's been enough for me today, and I guess for you as well, because that's not a short video. And I did learn something though. Like we are making good progress and learning stuff here and knowing how we look up error codes, and if we're too stupid to read them literally in here. We didn't find answers for everything, but we definitely learned some stuff. And if you didn't learn anything, then you're a pro, and congratulations. Congratulations for learning something today. It is always exciting to work with Solana stuff. Thank you for joining me here on this journey. And you can now check out those other videos and like this one. Subscribe if you haven't already. Follow me on Twitter, and then I'll see you in the next video, where we will create Solana NFTs with Metaplex. What? Okay, that's up for next time. Until then, bye bye.